Hi everyone. Today we're going to make inference about sample of a population. Um, by making inference, we mean that we are making a conclusion. We're making speculation, expectations, things like that. So we have like a few vocabulary that we have to know before we start our computations. Population, it is basically the entire group of objects. So we have the word population, the entire group of object. For example, if I'm talking about the school, I'm talking about the entire plumber students. So if I'm talking about seventh grade, I'm talking about all the students in seventh grade. Sample, it means that it is a part of the population, a group from the population that is chosen to represent the entire group. Meaning, if I want to make a conclusion or make a, what do we call an inference about Plummer Middle School, it's hard for me to go and ask each and every student in Plummer Middle School. So I have to take basically a group of students that represents the entire population of the school and survey them and then make a conclusion based on that information collected. Now, when I do that, it's kind of like I need to be careful not to be biased or choose a biased sample. What do we mean by a biased sample? Meaning, if I choose only students from seventh grade to represent Plummer Middle School, then that is a biased sample because in Plummer we have sixth grade, we have seventh grade, and we have eighth grade. So this is a biased sample. The same thing if I choose the sample to be all girls, that is a biased sample because I have boys and girls in the school. So I have to have what we call a random sample. Just pick any random students and that will be a good representation for our school. So biased sample is a sample that does not accurately represent the population. And for example, if we want to survey people about their favorite sports, it is not a good idea to go to, for example, a basketball game and wait at the door and then ask the people who are leaving the basketball game, because that's kind of like very obvious. Those people, they're here to watch the game because most likely they like basketball. So that is a biased sample. We can't survey that to ask them about their sport, their favorite sport. So now let's look at the parts for the computation in making inference from a sample. So we have a shipment to a warehouse consists of 3,500 MP3 players. The manager chooses a random sample. So it is a random sample of 50 MP3 players and finds that 3 are defective. Defective, that means they're not working properly. How many MP3 players in the shipment are likely to be defective? So notice that they want me to make a conclusion here or an inference about the total shipment. So we have the total shipment of 3,500. The sample that they had, it was just 50. So we can make basically a prediction using the sample that we have. Okay, so what are we going to do? And I need you to highlight this, write it in big. Always when it comes to prediction, we are going to use proportion. So proportion, proportion, proportion. This is one of the main concepts in seventh grade. It's used widely in many concepts. So proportion, proportion, proportion. Every time kind of like I have 3 numbers and I'm asked to do the fourth, that is a proportion. Every time I feel like, okay, I'm comparing 2 things or 2 quantities and I need to figure out one missing, that is a proportion. So here we're comparing the defective MP3 in this sample to the size of the sample, and we want to, based on that, we're going to compare that to the defective MP3 in the population to the size of population. So when we put it in numbers, probably you will see it easier. So the defective in the sample, we have a 3 defective in a total of 50. Always the total, it has to be in the denominator. So the total, it has to be in the denominator always. So this is the sample. 3 out of 50, they will be not working, defective. Now I will measure based on this. If I have a total of 3,500, how many will be defective? And we're going to figure this out. So one way to do this is kind of like, first of all, notice that we have an equal sign here. So basically I'm looking at two equivalent fractions. And remember, with equivalent fractions, we only using multiplication and division. We can't use addition or subtraction. Meaning, to make this fraction equal to this fraction, I ask myself, how can I make the 50 equal to the 3,500? And if I just hide the 1 0 and the 1 0 here, I can see the 5 and 35, basically. 5 times 7, it will be 35, but I have another 0, so that means it will be times 70, which means I have to multiply the 3 times 70 as well. And that will give us 210. So x, it will equal 210, which means we're expecting to have 210 MP3 players defective in the total shipment. So again, all what we do, set up a proportion and solve our proportion. So that is the first example. All right, let's look at the next one right here. We have Gerald buys a bag of 7,500 assorted beads online. A random sample, again, see, it's a random sample. It has to be a random sample of 150 beads. Contains 17 red beads. Predict, again, the word predict, the number of red beads in the bag of assorted beads that Gerald, or some probably is Gerald, bought. Okay, so we're going to set up a proportion. We're going to set up a proportion. So I have the sample and I have the total or the population. So I have the sample here, okay, and I have the total population here. So we know from this sample, which is 150, 17 will be red. So I know 17 red out of 150. If I have a total of 7,500, what would be the number of red beads? Okay. Another thing, we can see that there is a relationship between the 15 actually and 75. So whenever I have zeros, I forget about them. So I'm just thinking the 15 and 75. So I know that 15 times 2 is 30, times 4, it will be 60. So it has to be times 5. But since I have one more 0 here, it will be times 50. Which means I have to multiply the 17 times 50 as well. Which means x equal, I'll put the 0 first, then 5 times 7, that is 35. 5 times 1 is 5 plus the 3 that was carried, that will be 8. So we shall expect 850 red beads. So again, it is a prediction. So, and one of the things that I always tell my student, whenever you see the word predict, PR, that should remind you with the word proportion, the first 2 letters, proportion. So whenever you have predict, it always should remind you with proportion. And again, as you see, total beads, red, and then they asked me about red. So that's kind of like another clue. Red, beads. So that also gives you a sense that we are comparing, which means I'm using a proportion to solve a problem like this. Let's look at the next example. And if you're in the classroom, you would be doing this on your own, but We'll just go ahead and do this one together. So a store manager selects 30 cartons of eggs to find and finds, I'm sorry, 4 cartons that have cracked eggs. If the store has 105 cartons of eggs, how many cartons can she expect to have cracked eggs in them? The same thing, notice that expect, that's the key word here that tells me, okay, I'm using proportion. I want to make a prediction. Okay, so that is a key word here. The other thing, notice that we have cartons. So we have cartons, and then we have 4 cartons, and then we have cracked eggs, 4 cracked eggs. Okay, so we're going to make the proportion. We have the sample, and we have the population here. So the sample that the store had, so select 30 cartons of eggs and find four of them broken. So 4 out of 30. Okay, now if we have a total of 150, again, that's the total, always the total. I'm sorry, 105. Why did I say 150? 105. How many cartons will be broken? All right, so one way we can actually simplify the fractions sometimes to make things easier. But I think, let's see. Oops. Okay, so we can simplify this maybe by 2. So if I simplify this by 2, and whatever we do to the numerator, we have to do to the denominator. So 4 divided by 2, it will be 2. 30 divided by 2, it will be 15, equals x over 105. Okay, so now I can see, maybe I can find a relationship. Now, if you really good with your multiplication facts, or especially the 15 is easy to get, you should know that we multiply this by 7 to make it equal to 105, multiply this by 7, and we get 14. Now, if I can't figure out what is the number that I have to multiply by, we have 2 options actually. I can divide 105 by 15, and that will give me 7. So that tells me what is the factor I'm multiplying by. Okay? If I can't figure out, or the number is with decimal, then what we can do, we can cross multiply divide. So we cross multiply the 2 across from each other. So I have 2 numbers across from each other, so I multiply those 2. And then divide by the third one, which is the one that is sitting by itself. Cross multiply divide. So as you see right here, those are the 2 across from each other. So x, it will be equal to 2 times 105 and divided by 15. So just in case you can't figure out the relationship, okay, here, like what are we multiplying by, then you do cross multiply divide. Okay, so that will give us 210 divided by 15, which will give us 14. All right, that's it.